Today, we're gonna learn third chapter in chemistry, that is, metals and non-metals. First, let's see what are we gonna learn today. Physical properties of metals and non-metals. Chemical properties of metals. How do metals and non-metals react? Occurrence of metals. Corrosion. Metals and non-metals. Metal. A metal is an element that is typically hard, lustrous, malleable, ductile, and a good conductor of heat and electricity. Metals tend to lose electrons during chemical reactions and form positive ions, cations. Non-metals. A non-metal is an element that lacks the typical properties of metals. It is generally brittle, in solid form, non-lustrous, and a poor conductor of heat and electricity. Non-metals tend to gain or share electrons during chemical reactions and form negative ions, anions, or covalent bonds. Physical properties of metals. Metals are lustrous, shiny appearance. For example, gold, silver. Metals are malleable, can be beaded into thin sheets. For example, iron, gold. Metals are ductile, can be drawn into thin wires. For example, copper, aluminium. Metals are good conductors of heat and electricity. For example, copper, silver. Metals are sonorous, produce sound when struck. For example, iron, copper. Metals are hard. For example, iron, aluminium. Metals have high melting and boiling points. For example, gold, silver. Metals have high density. For example, iron, copper. Metals are solid at room temperature. For example, almost all metals except mercury. Physical properties of non-metals. Non-metals are non-lustrous. Non-metals are brittle, can be broken easily. Non-metals are non-ductile. Non-metals are poor conductors of heat and electricity. Non-metals are non-sonorous. Non-metals are soft, in solid form. Non-metals have low melting and boiling points. Non-metals have low density. Non-metals can exist in all three states. Exceptions in physical properties. Metals. Mercury, Hg, is a liquid metal. Sodium, Na, and potassium, K, are soft, can be cut with a knife. Zinc, Zn, is brittle, especially at room temperature. Lead, Pb, and mercury, Hg, are poor conductors compared to others. Gallium, Ga, and cesium, Cs, have very low melting points, can melt in hand. Non-metals. Iodine, I2, is lustrous. Bromine, Bridge 2, is a liquid. Diamond, a form of carbon, is the hardest natural substance ever. Graphite, another form of carbon, is a good conductor of electricity. Diamond again breaks the rule, very high melting point. Diamond has high density due to strong covalent bonds. Chemical properties of metals. Metal plus oxygen right pointing arrow metal oxide. E.g. 2Mg plus O2 right pointing arrow 2MgO. Metal plus water right pointing arrow metal oxide plus hydrogen. E.g. 2Na plus 2H2O right pointing arrow 2NaOH plus H2. Metal oxide plus water right pointing arrow metal hydroxide. E.g. CaO plus H2O right pointing arrow CaOH twice. Metal plus dilute acid right pointing arrow salt plus hydrogen. E.g. Zn plus 2HCl right pointing arrow ZnCl2 plus H2. Metal A plus salt solution of B right pointing arrow salt solution of A plus metal B. E.g. Zn plus CuSO4 right pointing arrow ZnSO4 plus Cu. This is the reactivity series of elements. The elements are in descending order with most reactive metals at first and least reactive ones at last. How do metals and non-metals react? Metals and non-metals react by transferring electrons to form ionic compounds. Metals tend to lose electrons to achieve a stable electron configuration, becoming positively charged ions, cations. Non-metals, on the other hand, gain electrons to complete their outer electron shells, becoming negatively charged ions, anions. The electrostatic attraction between these oppositely charged ions results in the formation of an ionic bond. Properties of ionic bond. They have high melting and boiling point. They conduct heat and electricity. They are soluble in water but not in kerosene, petrol, etc. They are solid in nature, but they are brittle as they can be broken easily. Occurrence of metals. Extraction of ores. Extraction of ores is the process of obtaining pure metals from their ores, which are naturally occurring minerals containing metal compounds. The extraction process mainly involves three steps: concentration, removal of unwanted materials like sand or rock; reduction, getting the metal from its compound using heat or chemical methods; and refining, purifying the extracted metal. The method of extraction depends on the metal's reactivity. Highly reactive metals like sodium are extracted by electrolysis, while less reactive ones like iron are reduced using carbon. Enrichment of ores. Enrichment of ores is the process of removing impurities like soil, sand, and other unwanted materials, called gangue, from the ore to increase the concentration of the desired metal. Different physical methods are used depending on the nature of the ore, such as gravity separation, froth flotation, and magnetic separation. This step is important before the ore goes through reduction to extract the metal. Extracting metals low in the activity series. Metals low in the activity series, like mercury, Hg, copper, Cu, silver, Ag, and gold, Au, are less reactive and are often found in their native state. If present as compounds, they can be extracted easily by heating alone or using mild reducing agents. These metals do not require electrolysis or complex methods due to their low reactivity. Example: 2HgS plus 3O2 right pointing arrow 2HgO plus 2SO2. 2HgO right pointing arrow 2Hg plus O2. Extracting metals in the middle of the activity series. Metals like iron, Fe, and zinc, Zn, fall in the middle of the activity series. They are usually found as sulfide or carbonate ores. Before extraction, these ores need to be converted into oxides by processes called roasting and calcination. Roasting is the process of heating sulfide ores in the presence of excess oxygen to convert them into oxides. Calcination is the process of heating carbonate ores or hydrated ores in limited air to remove moisture or carbon dioxide and convert them into oxides. After converting the ores into oxides, the metal is extracted by reduction with carbon, coke or coal, which removes oxygen from the metal oxide. Example: ZnCO3 right pointing arrow ZnO plus CO2. ZnO plus C right pointing arrow Zn plus CO. Extracting metals towards the top of the activity series. Metals at the top of the activity series, such as potassium, K, sodium, Na, calcium, Ca, magnesium, Mg, and aluminium, Al, are highly reactive. Because they react strongly with oxygen and other elements, they are never found in their free state in nature. These metals cannot be extracted by heating with carbon because carbon is less reactive than them. Instead, they are extracted by electrolysis of their molten salts. This process uses electricity to break down the compound and obtain the pure metal. Example: extraction of aluminium by electrolysis of molten alumina, aluminium oxide, dissolved in molten cryolite. Refining of metals. Refining of metals is the process of removing impurities from the extracted metal to obtain pure and clean metal suitable for use. After extraction, metals often contain impurities that affect their properties. Refining can be done by various methods such as electrolytic refining, distillation, or zone refining depending on the metal. For example, in electrolytic refining of copper, impure copper is made the anode, pure copper is deposited at the cathode, and impurities either fall off as anode mud or remain dissolved in the solution. Corrosion. Corrosion is the gradual destruction or wearing away of metals due to chemical reactions with substances like oxygen, water, or acids in the environment. It usually results in the formation of rust or other compounds on the metal surface, which weakens the metal over time. For example, iron reacts with oxygen and water to form rust, iron oxide. Corrosion can be effectively prevented by galvanizing, surface coating, alloying, which means mixing a metal with other elements to form an alloy that is more resistant to rust and chemical reactions. For example, stainless steel is an alloy of iron with chromium and nickel, which makes it strong and highly resistant to corrosion even in moist conditions. Alloy with mercury is called amalgam. Summary. Physical properties. Metals: lustrous, malleable, ductile, good conductors. Non-metals: dull, brittle, poor conductors. Chemical properties: reactions with oxygen, water, acids, and bases. Displacement reactions show reactivity differences. Reactivity series ranks metals from most to least reactive. Helps predict displacement and extraction methods. Occurrence and extraction of metals. Found as minerals or ores. Extraction methods depend on reactivity. Corrosion. Rusting of iron is a common example. Prevented by painting, galvanizing, etc. Alloys. Mixture of metals, or metal plus non-metal. Improves properties like strength, resistance. Thanks for watching. Subscribe for more.